Hello everybody and welcome to my poster. And with my colleagues from Warsaw University and the Polish Academy of Science and I, we do a cross-validation study between computer vision methods and sensor data. So the main idea is that we as developmental scientists are facing problems understanding how infants' complex movement arise. And those movements evolve not over time, over long periods of time, and also they change continuously. So we rely that with new methods like wearables and computer vision data, we can measure these infant motor behaviors in various situations and social contexts. However, even these methods, every time there are more, there is not a real comparison of what these computer visions can do in comparison, for instance, to sensor data, which is believed to probably measure movements more accurately. So in this paper, what we do is to compare one of these computer vision methods, the blood cut, that allows free choice of those body labels that you want to set, and compare that to wearable data that is in different locations of the infant body. So how do we do that? We tested infants from with the age between 4 and 5 months. We had sensors all over the body, so their limbs, their head, the trunk. But we used for this paper only the legs data, so to not overcomplicate things. Those data were measured at 40 and 60 Hertz, and we collapsed the data into measurements. One, it was acceleration data, so we collapsed X, Y, and Z acceleration data into one unique acceleration measure. And the other one was quantified quaternions that suffer less for drifts and is more sensitive to directional changes. And to compare with computer vision data, we used the blood cut, and we placed those labels in the same location where the sensors were. So we used 200 labels, we trained the algorithm for 1 million times, and then we got the movement data from that. What we observed is that the blood cut, the first thing we see is that it performs very well in both tasks. There were two tasks. One, it was a free play, was the high chair that you should show there where the infant was playing with rattles. And it was performing like with an error of 2 pixels. And even though, so with a test error of 4 and 6 pixels, in free play and in that chair, high chair position. So it's a very good, very low error, taking into account that the resolution was very high. And we found very high correlation, moderate correlation between DLC and both quaternions and acceleration-based data, but no significance when the data was shuffled. So we wanted to see if those correlations arose by chance, and those correlations were disappear when that happened. So what we see is that there is a good agreement between computer vision and sensor data. So the evolution of computer vision opened new doors for the analysis of movement data, and even we use an algorithm we tested with only 200 label frames, which is less than 1% of the total number. We track the movement very high with high accuracy, and the method proved to be robust. So when we compared those legs movement between both algorithms, we found that those correlations existed, so we can rely on these computer vision methods. So movement-based vision method analysis lends itself as a cheap, reliable, and unobtrusive alternative for measuring the dynamics of body movement of young infants in naturalistic interactions. And that opens new doors because we have huge databases of data, or we can plan new studies where we are going to record for longer periods of time and quantify that data. So if you have any questions, feel free to send me an email. My email is in the first slide or in the main poster, or see you around in the conference where we can chat about that. Thank you, and see you soon.